Hi, so this is the hands-on lab for Newton's laws. What I'm going to be doing, this is going to be like my coin video. I'm going to do the lab, and just explain everything all at once. For my box, this is my box I have, and I have some books up here that I'll add to the box. I'll do 3 trials. Once, the first time I'll push the box, I'll just push the box with nothing in it. The first time I'll push it with 1 book in it, and the next time I'll push it with uh, 4. How many do I have right there? 4 books. Alright, and I have my masking tape right here, so I'll tilt the camera down when I start. I'm going to put some masking tape down where I'm going to begin pushing, and then I'll mark it each with I'll mark it with a little piece of tape, the ending distance. Alright, and I know that this lab says find a level surface, a table, or a counter, but I'm just using my carpet because I'm too lazy to go downstairs. As you can see here in my box, I've marked, I don't know if you can see in the video right now, but I've marked my ground. This is where the end of it is going to be when I start to push it. I'll put a barrier here. I'll put a book right here to mark the farthest possible that it'll go. The book will just stop it. And then I'll just lay on top of my bed and kind of inch it off. Or well, not inch it off, but that's where I'll lay when I hit it off so that nothing interferes. Okay, this will be the trial number 1 with nothing in it. Shoot. Alright. So that was the first time. I kind of explain as I'm doing it, or as I'm marking it down. I pushed it. I didn't want to push it too hard because I didn't want it to fly across the room. But I used, not very much force. I got it. I would say just maybe 5 inches away from the yearbook, from this corner to the end of the yearbook. I have some books right there. They're not too big, but either way, it'll still add some weight to the box. I'll just mark this down. Alright, so that'll be 1. I'm resetting my box, and here is the book that I'm going to use for my first one. So we'll see if that adds any difficulty. Alright, so that was my second trial. I pushed it almost to the exact same level as I did the first time. It felt as if I used the same amount of force. And my logic of why it went to just about the same distance is because there's only 1 book in there, I didn't really add a lot of weight to make a difference. Let me just write that down. So now that I realize how little 1 book did, I'm gonna add 3 books, and that same 10-pound weight I used from the coin lab. I'm sure we know how this one's gonna go. Alright, so there's the third and final trial. Obviously, I tried to push with as much force as I did the first 2 ones, and it got not nearly as far. I would even say less than half the distance than I did the first 2. I'll just mark this piece of tape down so you can see in comparison the first 3 trials. Yes, at this point. Okay, so I just kind of overlooked the taping here. Here's where the first one went. This was with nothing in it. This was the farthest. This was with one book in it, which didn't make much of a difference. It was, I would say, just 1 inch apart from the first trial, and then here's the third one I just did with the 10-pound weight and the 4 books. It's just about halfway in between from the starting tape and the second trial right here. But a little less than halfway from the initial starting point to the yearbook. I'll go ahead and do and answer the few questions right now. Which of Newton's laws applies to this lab? Explain fully. I said the second law, which is force equals mass times acceleration. As the mass increased, more force was needed to accelerate it at the same rate. As you saw by my trials, the first my cat's just playing around. The first and second trials with little to no extra objects in the box made or got it almost all the way to the yearbook, whereas with the 4 books and the 10-pound weight, which was a lot more mass and weight than it was the first 2 trials, it was very hard to move it as far as the first 2 trials. And question number 2, what happened to the amount of force needed to accomplish the task when cans or books were added to the box? Explain why. I kind of just answered that in question number 1. The force, it increased, obviously, because with the more mass and the more weight added each time, it took more and more force for me to push it as far as it was to get it going at the same rate to get it to the right, or to the same hash mark it was at.